We are currently drawn to a wonderful structure in space that is so enormous that it affects the orbits of entire clusters of galaxies. We don't know why or how this voyage will conclude, but this enormous thing called the Great Attractor is moving our entire galaxy inexorably. There are still many unresolved issues surrounding the Great Attractor. We can only be certain that it is among the most potent occurrences ever discovered in space. It might be a vast collection of dark matter and intergalactic gas that together produce an unfathomable gravitational pull, or it might be an unidentified cosmic entity whose actual characteristics will expand our knowledge of the cosmos. Imagine gazing into the cosmos and all of a sudden seeing something enormous, so enormous that it ranks among the largest objects you have ever seen. Scientists have discovered the Great Attractor in the Norma cluster, or AEL 3627, a region of space. The Laniakea supercluster, a massive group of galaxies that encompasses our Milky Way, is centered on this cluster. Look in the vicinity of the constellation Norma to get a general sense of the location of the monster object. Although the Norma constellation is not very noticeable in the southern night sky, it can be located if you first locate the well-known Scorpius and Sagittarius constellations. Between these two more noticeable constellations to the south is the constellation of Norma. Because it lacks any exceptionally bright stars, it is quite difficult to view with the unaided eye, especially in urban areas. You can therefore visualize the Great Attractor, a huge gravitational anomaly that most likely influences the general motion of galaxies within the Laniakea supercluster between Sagittarius and Scorpius. The distance between Earth and this anomaly is roughly 150–250 million light-years. Even astronomers with the greatest telescopes in the world struggle to pinpoint the Great Attractor's precise location because it is hidden behind the Milky Way band, a thick region of gas, dust, and stars that makes it difficult to see. This region of the sky is known as the zone of avoidance by researchers. Because of its position behind the band, it is quite challenging to observe this phenomena directly. We are aware that it exists, nevertheless. It's difficult to overlook the Great Attractor's impacts. The Great Attractor's center is probably formed by the Norma cluster. The cluster exerts a strong gravitational pull because it is a huge assembly of galaxies. The mass of the Great Attractor is believed to be between 10^16 solar masses. This implies that the Great Attractor might be much more than a vast galaxy cluster. The galaxies might simply be the outward manifestation of the real force causing the attractor. Our Milky Way and the Virgo galaxy cluster are among the galaxies that are impacted by the attractor's strong gravitational pull, which is caused by its massive mass. What part the attractor plays in the vast cosmic stage is called into doubt by this revelation. Does it serve a very particular purpose, the deeper connections of which we do not yet understand, or is it random? Researchers believe that the Great Attractor might be hiding a force in the cosmos that hasn't been discovered yet. However, what creates such a powerful gravitational field? Is it an ultramassive black hole with a gravitational field so powerful that it can enchant entire galaxy clusters? Alternatively, it might be a massive mass of dark matter and cosmic gas that creates an unfathomable gravitational pull. What is the attractor exactly? It's an amazing notion that something is continuously enchantment us from someplace behind trillions of stars and hundreds of galaxies. For several decades, we have been aware that most galaxies have a supermassive black hole hiding in the center, and that these black holes are in charge of the motions that occur within the galaxies, among other things. They also create a sort of attractor with their suction force. Matter is continuously drawn to black holes inside galaxies, and if it is near enough, it is enchanted by the black hole and never leaves. We are unavoidably approaching the terrifying possibility that the Great Attractor is a much more potent black hole that may swallow entire galaxies. Currently, scientists think it's very plausible that the huge gravitational pull that is causing entire clusters of galaxies to move is coming from a supermassive black hole at the center of the Great Attractor. The cosmos may contain even larger-scale structures than those discovered at the galaxy level. But the possibility of an ultramassive black hole in the Great Attractor's core also begs the question of how these kinds of structures form and what processes enable such a mass buildup. The idea that the Great Attractor is a massive collection of galaxies, intergalactic gas, and dark matter is another commonly held belief. Together, these elements might produce an unfathomable gravitational pull, akin to that believed to be present in the Great Attractor. The key component of this hypothesis is dark matter, which accounts for about 85% of the universe's total mass. One of the universe's biggest mysteries remains dark matter. Although it cannot be seen directly, it affects how galaxies and galaxy clusters travel. The observed gravitational effect may potentially be well explained by a very high concentration of dark matter in the Great Attractor. In this scenario, the Great Attractor would be a giant supercluster or large galaxy cluster, the exact nature of which is still hidden by dark matter. The Great Attractor has enormous ramifications for our comprehension of the cosmos, regardless of which theory is true. We are just beginning to investigate the dynamics of galaxy clusters and the universe's large-scale structures. In addition to offering us entirely new perspectives on the makeup and distribution of dark matter, the Great Attractor may be crucial to our comprehension of the entire universe. The Great Attractor is presently being seen through the zone of avoidance by researchers. Future developments in astronomy and telescope technology will help us better understand this mysterious occurrence and, ideally, help us discover all the mysteries of this intriguing structure. The dipole repeller is an even more potent force. In the expanse of the cosmos, amazing discoveries continue to be made. This is due to the fact that scientists have discovered the Great Attractor, a cosmic repeller that functions similarly to the point of attraction. This phenomena has only recently been identified and is known as the dipole repeller. It's interesting to note that this repulsion anomaly is the ideal analog of the Great Attractor, and is likely a crucial component in comprehending the movements of our local galaxy cluster. The dipole repeller is situated nearly opposite to the Great Attractor and is roughly 450 million light-years away from Earth. It is a vast area of space with a very low density of galaxies rather than a physical object like a cluster of galaxies. Another way to characterize the repeller would be as a big emptiness, but that's probably not the case. The dipole repeller must also have some sort of structures and forces, even if it has fewer galaxies than the attractor. The subdensity is the source of the tremendous repelling force. Galaxies are only driven away from this location in a totally different manner than the attractor due to this influence. When studying the motion of galaxies, this cosmic oddity was found. The gravitational forces affecting the Milky Way and its nearby galaxies were mapped by scientists using information from the cosmic microwave background radiation and the dispersion of galaxies. Scientists were astounded by the prominence of this area of intense rejection. Although unexpected, the dipole repeller's discovery was groundbreaking since it provided insight into a hitherto unknown aspect of the local group of galaxies: motion. Understanding the role of dense and empty regions on a cosmic scale will be made easier by the discovery of the dipole repeller, which throws a whole new light on the universe's intricate structure. These dynamic interplay between attraction and repulsion in the cosmos's large-scale motions may also reveal the structure of the universe and the forces, some of which may have been unknown before, at play. Is there a huge void in the repeller? The precise definition of the dipole repeller is called into dispute. According to the dominant view, it is a vast area of space with an underdensity in the universe. Where there is less mass, items are pushed away, whereas heavy objects draw others to them. The dipole repeller is a region of space where the gravitational force is weaker than in the nearby, more crowded areas of the cosmos, rather than a physical object in that sense. The dipole repeller is particularly intriguing because some scientists believe it, like the attractor, may be related to dark energy. It's possible that areas like the dipole repeller have higher concentrations of dark energy, which repels nearby galaxies. On the other side, dark matter is thought to have an impact on the attractor. Among the universe's most enigmatic elements are dark matter and dark energy. It is also possible to compare the dipole repeller to other known cosmic gaps. These gaps are vast regions of the cosmos with a comparatively low number of galaxies. They are a component of the vast network of voids and galaxy clusters that make up the known universe. It's possible that the dipole repeller is a particularly noticeable emptiness with a gravitational pull powerful enough to affect nearby galaxies' motion. The cosmos is an incredible cosmic network, yet in many respects, its makeup and architecture are similar to those of a living being. Surprisingly, regional groups, the dipole repeller and the Great Attractor, and the morphologies of galaxy clusters and superclusters do not exhibit the spherical, spiral, disk, or vortex shapes that are typically found in the cosmos. These structures seem natural, even disorganized. Compared to the galactic plane's harmonious geometric shapes, we appear to be on a totally other level of the universe here. The study of the universe's basic structures is still in its early stages. The cosmic repeller and attractor phenomena offer potential new clues to the enigma of our universe's fundamental structure and nature. Based on an enormous network of galaxies, galaxy clusters, filaments, voids, and other cosmic phenomena, the universe is an incredibly vast and intricate structure. Cosmic development over billions of years has produced the network we see today. Only until we have a better grasp of the two great unknowns, dark matter and dark energy, will we likely be able to fully comprehend the intricacy of the universe. It is estimated that they comprise approximately 95% of the cosmos. Practically speaking, this indicates that we currently know very little about the majority of our cosmos. Only observable matter and its dynamics are visible to us. Although we are unable to directly measure or view them, we are aware that both must exist due to the impact of the dark aspects. About 27% of the universe is made up of dark matter, which is most likely essential to the development and stability of galaxies and galaxy clusters. About 68% of the cosmos is made up of dark energy, which opposes gravity and is believed to be the cause of the universe's fast expansion, among other things. Huge filaments of intergalactic gas and dark matter have been found by researchers between the clusters of galaxies. Like a nervous system, these filaments constitute an intriguing cosmic network that permeates the entire cosmos. Join us for every new video by subscribing today.